This video we're going to run through several of the synthesis reactions for alcohols that we have already seen throughout this course, both this semester and last semester. It'll be brief, but you're more than welcome to go back and look at these reactions and the videos that go with them from previous chapters. So two reactions of alkenes that we talked about that give us alcohols are hydroboration oxidation as well as the oxymercuration demercuration. So there's a couple of different things to keep in mind with these reactions. So one is the orientation of your product. So hydroboration oxidation, you're going to get a syn addition, meaning the alcohols are going to add to the same side of the molecule. And then you're also going to get anti-Makovnikov addition, which means the alcohol group is going to add to the carbon with the most hydrogens. So Makovnikov addition, remember, means that the hydrogen adds to the carbon with the most hydrogens. So anti-Makovnikov would be the opposite of that. So the reagents that you're going to use when you're doing the hydroboration oxidation, it's two steps. You've got BH3 along with THF. And then in the second step, you need hydrogen peroxide and sodium hydroxide. Then the oxymercuration demercuration, we are going to get syn addition as well. However, it's going to be Makovnikov addition. So again, your hydrogen is going to add to the carbon with more hydrogens. The alcohol will add to the carbon with fewer hydrogens. So let's look at just an example of each of these and see how they are different. So I'm going to start with this alkene. If I do the hydroboration, we are going to get, like I said, syn addition. So that means if the methyl group that's already there comes forward, the hydrogen is going to add to that tertiary, what is now a tertiary carbon, because that is the carbon with the fewest hydrogens in the starting material. So this is the anti-Makovnikov addition. And then the alcohol is going to add to the other carbon that was the double bond. And notice how the hydrogen and the alcohol that I've added are both going backwards. That's the syn addition. They're on the same side. Because we have chiral centers here, we are also going to get the other option. So the methyl group goes back. The hydrogen is then forward along with the alcohol being forward. So again, we need to remember stereochemistry. And if you get more than one enantiomer or more than one diastereomer that forms, make sure that you're showing each unless you're otherwise told to not. If we look at our other option here, the oxymercuration, and I believe I forgot to write these reagents on the previous slide, so here you go. So here's the mercuration step, here's the demercuration step. Again, two steps. This time, again, we're going to get syn addition, but now the alcohol is going to add to the carbon with the fewest hydrogens. So it's going to go up here and become a tertiary alcohol. Now the hydrogen, because was already a hydrogen down here, the one we're adding, we don't see the difference, but the two groups that are being added are again being added syn. This molecule is achiral. We do have a mirror plane down the middle of the molecule, so we don't have to worry about forming enantiomers or diastereomers because both options that could possibly happen are actually the same molecule. Another reaction involving alkenes and producing alcohols are the formation of diols. So here we're going to be adding two alcohol groups at the same time. And we've got two options. Both of these options are going through epoxides. The difference is how we are actually reacting and opening that ring, whether it's acidic or basic conditions. So the first option, if we use these reagents, we're going to get syn addition. So if we want those alcohols to be on the same side, we get syn addition, we'll use those reagents. If we want anti-addition, we have reagents that will do that as well. So again, both go through epoxides. If we want to look at a couple examples, we'll use the same alkene as we did in the previous slide to start. If we use the osmium reagents, syn addition, that means that both of the alcohol groups are going to be on the same side. So if my methyl is forward, both alcohol groups will go back. Again, I've got chiral centers, so both alcohol groups could add to the front instead. So both are options. If I want the anti-product, oops. If the top alcohol adds to the back side, that means the bottom one's going to add to the front. Again, I have chirality to consider. The other option is a different molecule. So both are possibilities. Again, if you need any more details or practice on any of the reactions in this video, they have been covered in previous videos, so please feel free to go back and take a look at those.